Derek Jones. I'm Associate Professor of Cognitive Science and Director of the Cognitive Science program, as well as Faculty Director of the Center for Innovation and Change. The thing that I've come to love the most about teaching is sort of seeing students develop from that first year where they really want to be told what to do, and they're really anxious about, please, just tell me what the paper requirements are and I'll do the requirements and so on. And sort of seeing them progress from that as freshmen to being really sort of self-possessed, empowered students by their senior year that are engaging in their own research projects, that I can give them information about some new study and they can immediately sniff out whether or not there's work to be done there or whether it's even worth pursuing, and they can distinguish good science from pseudoscience. And I can kind of see them by the time that they've graduated, they're going out into the world able to sort of separate the wheat from the chaff, right? The good ideas from the maybe not so good ideas, and also to be able to start striking out on their own research problems and doing work for themselves. And it's really cool to see them sort of grow into those abilities over the course of a few years. Teaching cognitive science it's a lot of fun because of how interdisciplinary it is, but for the same reason, it also requires a lot of introductory work sort of on the front end to explain what it is, what distinguishes it from psychology and neuroscience and so on. But once we get that going and everyone gets the sort of basic toolkit in place and is able to sort of distinguish the relevant positions and focus on sort of the real problem areas, it's a really fun area to work in, specifically because there are so many open problems that have yet to be sort of, conclusively determined. It's a science really in sort of its earliest stages. And for that reason, there's a lot of really cool theoretical work that's still available and a lot of work that we can, there's a lot of uncharted territory, I guess. Yeah, cognitive science is for any student that's really interested in what intelligence is, what the mind is, what you are, but maybe you're not ready to commit to one particular discipline, right? So cognitive science uses concepts and methods from a whole bunch of participating fields, right? Philosophy, neuroscience, psychology, anthropology, computer science, robotics, right? Biology, economics, math, data science, right? There's a whole bunch of different areas. And the idea is that it's all of these different fields working together to sort of look at what intelligent systems are, what distinguishes things like you and me from things like computers or rocks or hurricanes or plants or whatever. Some configurations of matter, right? They just kind of sit there. Other configurations of matter write poetry and fall in love and run for Congress. And so the question is, what's special about those other configurations, right? And well, once we've pinned that down, then, well, what are their properties? What makes them the kinds of things that they are? My teaching style tends to be sort of a mix of modeling certain kinds of intellectual virtues for the students, and then getting them to start working on their own. So by the modeling intellectual virtues, you can lead a horse to water, but you can't make him drink, right? The goal one is to show the horse that the water is really delicious, right? So I need to be able to show them why they should care about the subject matter in the first place. And the way that I do that is, through games, through sort of hands-on activities, and also sometimes just through, what David Hume called emotional contagion. Just being up there and genuinely showing what I find to be really, exciting or fun or, even, sort of amusing or beautiful about a particular problem, and sort of allowing that enthusiasm to catch. And the other piece is trying to provide the students with just enough information to work with to where they're willing to take the next step for me, right? So provide them with a puzzle, right? Even in science classes, right? Provide them with a puzzle and let them try to figure out how to solve that puzzle. And then we come back and we say, okay, what was your solution to this? Okay, here's how it was actually done. Now let's move that next bit forward, right? But that's forcing the student to take sort of a more active role in how they're learning. If they're just sort of passively sitting there letting the words wash over them, and believe me, I could fill 50 minutes, no problem, it's not going to be nearly as good for them as it is if they are being really encouraged, right? Both by showing them, hey, this is going to be worth your time, but also, laying the problems out in a way to where they are empowered to then start actively learning on their own. And it's a harder job, but it pays off a lot better, and I think the students are a lot better off for it.